takes in parameter lists such as this list of tuples. You initialize two lists, empty ones. Then I iterate over the list. Fe, Fi, and Se are for first and second item of each tuple. You can put whatever you want. And then I append the first element of each tuple to Li1 and the second to Li2, and I return it as a tuple. And the second one.
Are there questions on the zip2 solution? I think almost everyone had the same solution, but if there are questions.
Yeah.
Okay, thanks.
And to invert. So invert Git items gives you a list of tuples, key values of your dictionary. If you do any dictionary dot items, give you a list of key values, exactly like the list we had for that we entered in the zip2 function before. So I can iterate over that and reverse the key. KV stands for key and value in the two items of each tuple, and I reverse, and that's it. Return a new dictionary.
Any questions on this?
Thanks, Florian.
Thank you.
You're welcome.
Did even have to describe
Yeah. Good.
It's something.
Very lucky.
It's like
Okay.
it works directly. That's why I got mine. This
I
kind of
have
stuff.
That one is
The other
a
VM, like, the other VM inside you ask for.
I know it's your
ones.
project, it's not really connection. So, now, since all of these are containers, you may want to ask yourself, oh, is this element in this container? Yes, you can do it with the in keyword. Basically, you can use it on almost any kind of container. The difference is that depending on the container, you get a different meaning. For instance, if you ask if a specific element is in a sequence like a list, you get true or false depending on the answer. If you try to use it on a dictionary, in this case you're asking if that particular key is in the dictionary. So you cannot do it for the values. And if you do it with a string, this will work on a substring as well. So not just a character, but also a string.
Question?
Yeah.
How do you test? It's a question to the audience. If a particular value is in the values of a dictionary.
If you do it on value.
Yeah, exactly. Congrats.
So those is case sensitive, strings are case sensitive. This case is closed, but they can do this. So, okay, this is the test I just did. And of course you can put it in a if statement and whatever, because X in a container returns a boolean. So this is more recap of the structures we have seen. I've also used frozen set, which is the a mutable version of a set. So you can use frozen set for keys of dictionary. And you can see that we don't have an equivalent in the standard library for a dictionary which is immutable, or a mutable sequence of strings. Now, next step. We are already seeing the Visualize Python website, which is really useful to understand exactly how a few things are implemented. And the example, or the question I would like to make, why there is the solution here? I didn't want to put the solution here. So, my mistake. So the point is, Riccardo already told you that a variable name is just, let's say, a pointer from an object. It's not the object itself. And when you do an assignment, you basically create a new name for the same object. So when you run this, and then you run this assignment, B and A points to the same list. You are not copying the list, you are not creating a copy of the list. Which means that if you try to remove an element from this list, for instance, this is removed from the only object you have, and you get this. So in order to show you this, let's try. What happened in the Visualize Python stuff. So first of all, I create a list and I assign a name, which is A, to that list. So you have the list here and this is the name. Then the assignment B equal A just create a new name for the same object, but no copy of the object has been done. So when I run remove, the element is removed from the only list we have. And when I print it, I print what is inside.
But the question is, if we need to really create two copies, that if we need really to go on that at this moment, this copy point to that, but I manipulate one parameter and the other stay constant, then maybe I can compare later on.
There is a module called copy to create copies
Okay.
of stuff. For this, actually, it's even easier because you can use the syntax we use for the slicing. Because when you create a slice, you create a new list. So you can create a slice containing the whole list. So it's a new list, and you can do this. So if you do this, oops, you manage a list. So in this particular case, for this, you can do this. And A and B are different.
But what does it mean, this dot?
This is the slice, how is it called? This is how you access a slice of a list. You remember, you can specify, for instance, starting from 0.
Yeah,
only
so if you specify no
elements.
it's everything basically.
The whole
If you don't specify anything, okay, if you don't specify the first one means start from the beginning.
Yeah.
If you don't specify the last
Go
one,
to the end.
means go to the end. So this is
Right,
shorthand
and
for
specify all, but it's a copy here.
this.
Ah,
This is a shorthand.
And it
This
makes,
is a shorthand for this.
and it makes a copy.
It makes a copy because the
One by
slice,
one, yeah, it's
when you
like-
slice, you create a new list. But this is really important to remember because when you call a function and you pass a list to the function, for instance, and I've seen some of you did this, let's say, mistake. you modify the list, the argument passed to the function. So you were actually modifying the same object the caller was using to as a parameter for the function. This may be what you want, but more often it's not what you want. Well, it really depends on the program you are developing. But you have to, if you do this, you have to at least document it on the function. Please take care this function is modifying its argument.
So if you just want to have a temporal work on a variable or on content, then you better make a local copy first, work out that, and you still keep your original.
No, I'm not sure I'm following.
So
But
if
in
I don't
principle,
want-
if you plan to modify, if you want to create a new list, which is a slight modification of the list of the argument you passed, you usually create a copy inside the function
Yes,
and then
exactly.
return it.
Yeah.
Otherwise, there are other functions which
Yeah.
actually need to modify
Yes, yes.
the object in place. In C, for instance, you have pointers, so you know that you are passing a pointer, so you know that this may change, but you also have the const, so you can, it's a bit, let's say, hidden in Python. When you pass an object to a function, and the object may do something with that object, also modifying its state. So this is what we already saw. If you want to create a copy of an object, a generic object, not just a list, there is a module called copy. You import copy and you call the copy method inside this module. And it's really simple. So in that case, I'm not modifying the original object because it's a new object has been created. It also works with dictionary or almost any other object, but this method creates a shallow copy, which means if you have a nested data structure, it doesn't change, it doesn't copy all the nested elements. For instance, if you have a dictionary and the value of dictionary is a list, which is a visual object, you create a copy of the dictionary, so E is now a copy of D. If you modify the value of this dictionary, even if it's the copy of the original dictionary, the list contained in the original dictionary is actually copied.
Probably can show this with a Python tutor, so
Yeah.
it's more like this.
So the point is that this is when you create a copy, it's basically copy a reference to that object. In this case, when you run copy. So let's see again on the visual stuff.
The only thing.
So
It should be E equals copy D and not E.
oh, sorry. Yes. Thank you. That would erase an error. So first of all, we create a dictionary. Then, import copy. Take on message. Visual Python doesn't work with everything.
It's okay. So you meant
But okay, this is not what I wanted to show you, but this is basically like
And the import command can be anywhere inside the code.
But for readability, it's usually
At the top.
at the top, yes. So this is doing copy manually just because this is what actually happening when you create the copy, when you call copy.copy. So you see the A key doesn't have a copy of the list, has a pointer, a reference to the list containing the it copies the keys and a reference to them. If it's string or integers, it's a bit corner case, but if it's a mutable object, it's always a reference to the same object. So in that case, you see that it's just a reference. So you may ask, okay, but I really want a real copy of this dictionary. Well, there is a method called deep copy. Deep copy is slower, of course, but it's actually basically it's visiting the whole values of all the attributes of this data structure, all the stuff contained, and it's copying everything.
Yeah, but I have a question. If it's just copy, it's just the same as equal. You can use like no?
No. Because if you do equal, okay. Let me open up terminal again. So we have okay. D equal it's different. So if I do this, yeah, different. I'm reassigning the same. But if I do this,
If it is the same
Yeah.
so in this case, I'm copying a reference to the same dictionary, which is this. In this case, I'm creating a new object, a new dictionary with the same key and reference to the same values, to the same number. Okay. Functions. Now that we have seen dictionaries, etc., maybe this is more easy to understand. You can create functions, which are, well, until now we created a function that accepted a fixed number of arguments, 1 or 2 or whatever, call it 1 now. So if you try to call that function without argument, you will get an error. If you try to call it with multiple arguments, you get an error. You can create functions that accept optional arguments. For instance, the hello function may accept an optional name argument, the function we wrote this morning. And the syntax to create this is very simple. It's like an assignment, but it's not an assignment. You specify the variable name that you will find inside the body of the function, and the default value that variable will have if the function is not called with that specific argument. So in this case, if I call hello without any argument, name, the variable name will be replaced with word. If do we have an example? No, okay. If I call it with an argument, in this case, name will be replaced with the string I passed, the argument I passed. Any question on that?
In C++, I think the parameters that accept some argument should be at the end. Here can be anywhere.
Okay, the optional parameters, actually also in Python. But I think we have an exercise after one example with no, maybe later.
There should be
But
an
yes, in principle you can have mandatory arguments and optional arguments. And when you define a function, you have to specify first the mandatory arguments and then the optional arguments. So it's more or less the same. So there are functions though that can accept a variable number of arguments. For instance, mean or max functions, you can just specify how many numbers you want, not just a list, but you can call it with this. So how can you create a function that accepts multiple arguments without knowing how many? Well, you do it with this special star character that when you use the star character, actually the name following the star character is going to be a tuple. And inside the body of the function, you will have this tuple and you can iterate over this tuple. So, for instance, this is a simple function which is accepting a variable number of arguments. It will print all these arguments. If you call it with 1, 2, 3, it will return, it will print this, which is a tuple. It's not a list because it's usually more efficient. Well, it's more efficient than tuple. And in this case, and this is the example it's similar to the things we were discussing before. If you want to create a function that accepts a number of mandatory arguments, but can also accept multiple arguments, you can do it by specifying the mandatory arguments and optional variadic arguments. So in this case, you can call it with just 2, I guess, or to choose. Or yes, it has to be at least one. But it could be also an empty tuple. Yes. So you can do A, B. So if I call it like this, I get an error because I need to specify at least one argument. If I call it with 2, args is going to be an empty tuple. And if I call it with more arguments, the tuple will contain all the remaining arguments. Now, if you have a function like this that accepts a variable number of arguments, and you have these arguments inside a sequence or a list, a tuple, whatever, I mean, how can you do it? You cannot really do it easily with Python itself unless you use with what you have seen until now. But you can use the start argument to explode the list. And in this case, when you explode this list using this syntax, programming the asterisk, the star before the list, this is converted in the call function we already see. So L is a list, var this is equal to call this. It's different from calling this because this would be calling a function with a list as an argument. So in that case, you will have a tuple containing one element, which is the list.
But in that case, it will be the same object?
No. In the same respect of what?
Like,
Everything you call the function, a new tuple is created containing the argument. If you call this, it will be a tuple containing only one element, which is exactly that list.
Yeah, but I mean the first example. It's gonna be like 3 and 3, but
I'm not sure I follow.
no.
So you-
No, it's okay.
Okay. So optional arguments are also they are not just optional arguments in the sense that when you have a function which that accept multiple optional arguments, the order doesn't necessarily matter because you can specify exactly the order. Well, rewind. This is an example of a function that accepts two optional arguments called numerator and denominator. Now, if you call it it's the same. Ah, perché questo è definito diversamente. Ah, okay. Right, my fault. That's a bit confusing.
Do you give names to your parameters and
So,
you can instead of
yeah, the point is when you have the
because
the
you
definition of the function define the names, you can, if you don't specify, if you call it in this way, you can, you don't care about the order
yes,
inside
because
the
they are
definition.
explicitly referred to, and if
Okay,
they don't
yes,
have names,
that's
you
right.
have the order is
This is
explicitly
the point.
referred.
I'm sorry,
So you
I
can
forgot
bind
this slide, so I totally forgot about this.
You can bind actual arguments
Yeah.
to formal arguments, so those that are specified in the function definition by position
Mm-hmm.
or by
By
name. If you bind them by name, then position is irrelevant.
Yeah.
So this is giving an error, of course, but if I call it like this, A is equal 1, but if I call it like this, A is 2, even if it's the second argument.
So both options
Sorry
are
for that.
valid. By
Yes,
position or by
yes. You can call them either way. In some cases, this is more convenient because, especially if the signature is very long, you have multiple parameters. This is
Condition.
easier to force the correct behavior.
But that's add complexity at the programmer, like we shouldn't
It may complicate your program, yes.
we should focus like with naming the variables and program.
It's very useful. For instance, like I'm using connection object to OpenStack. Like the connection has like 12 parameters.
Okay.
So sometimes you only use 6 because you don't need all of them. So you use whatever order you want as long as you put the tenant name, tenant ID, whatever. You don't need to put the ID before the name. You can just put whatever you want.
Ce l'abbiamo dopo dello stanza, poi già lo stanza. And it's also convenient, we'll show you in the next slides, when you have a dictionary with key and values, where the key are the names of the parameters and the values are the values of the variables. But this is in one of the next slides, if I remember correctly. So, you can also create a function that accepts a variable number of named arguments using a similar syntax to what we saw before, but using two stars. In this case, k